Thanks for everyone joining another week. As you saw by my email, you see Lucy's here too. So Lucy from University of Pittsburgh, from the BMI, the Vascular Medicine Institute at the University of Pittsburgh, will be giving a talk today after I give the brief update. But so stay tuned for that. You don't have to hear me talk the whole time. No new papers that I know of from the group yet, but this one preprint I think hopefully should be accepted soon on mitochondria. As I say every week, we're working on. Al has some interesting long COVID case reports. We met again Monday, I think we met. So we were going over that, and people interested in joining. There's lots of data to kind of mine and tackle for that data. So if people are interested in joining, send me an email, and then we can get you out. Could get you part of the group and share the data. And the hope is from these patients who are experiencing these unfortunate long COVID unique cases, we could maybe have some kind of guide of what's happening to them or some discovery. Okay, let's go into the news. As we know, the XBB variant is taken off the new ones, the 1.16 and the 1.9.1. In China, they're predicting by the end of June, they're going to see this new spike potentially happening, since they don't, like in most places around the world, there's no restrictions anymore. So they're predicting that 65 million cases per week could happen by the end of June. What we've been discussing the past few weeks is that even though these two variants of XBB are causing these spikes and having more infections occur, it seems like the severity and the hospitalizations and things related to that are not going up, which is good to hear. But we'll see what happens in China and then how that spills over to the rest of the world. And also some people there have hypotheses to say that potentially why this is the case also is that there's a kind of a background high immunity, because a lot of people have been infected too, although that wanes after a while. There's this new CDC study, which is here on this middle down part, that just came out. But they're talking about, it's probably no surprise to anyone, but if you haven't had your booster, which I'm sure everyone here has, they show basically that, if you have your booster among adults, that there's, 62% chance here up to 3 months after it's administered that, the effectiveness of reducing hospitalizations. And then, as we all probably know this already, after 6 months, the public doesn't necessarily know this, but we probably do, is that, it starts waning to 24% protectiveness for compared to unvaccinated adults. This is the study here. The link is down here, and I'll send you guys the slides like usual. But so I know we've discussed this before, and I know a lot of folks say we should probably get our bivalent booster updates every 6 months, although there's no update to like the previous bivalent boosters, the same one that came out for BA4 and BA5. And then, in the study, the really brief report study, they say, if you, for critical illness, update the shots, sustained protectiveness of critical illness, and then, up to 6 months again. So for people that doesn't have the bivalent booster, and since this XBB.1.16 and 1.9 is coming up, I would recommend for people to get it, or maybe get an updated one if it's more than 6 months. Another, I guess, news is that you probably read this. FDA has full approval for the Paxlovid, so that's good. So people might be able to get easier access to it now too. And then a couple of papers we'll go over. I'm going to go over this quick to give Lucy enough time to talk. One paper is talking about this from the Japanese study here. This paper in PNAS that came out a few days ago was looking at obesity models and talking about how, which again might not be a surprise to people, but it's going to be good for the inflammation paper people are working on that. Talking about the obesity model, how and what factors might be related to producing more of a cytokine storm when you get this obesity. So here's some figures from the paper. They looked at a patient population, and then they looked at mice, did some mice studies. So there is actually omics data from the mice studies that people wanted to, available somewhere, people wanted to mine and look at what's happening. They specifically looked at pathways related to inflammation, so I'm curious to know if mitochondrial pathways popped up here, which I'm sure it probably did, but they did only specific targeted analysis here when they looked at their omics data. But what's interesting in humans, this is the human data from the patient population. They show, this is looking at the vascular, adipose tissue. They see again the survival rate here. If you're more obese, has probably not surprised anyone. There's more of a chance of mortality, I guess, or the survival rate is more poor for that if you are infected. And then there's some studies, and then they looked at a lot of key inflammatory factors are kept popping up in their mouse model, for the obese mouse model, that might give insight the mechanisms behind it. But a lot of things are related with IL-6, interferon activity. There's some genes here that popped up that are overlapping with what we see in our inflammatory paper that hopefully is almost done soon. So that's the brief paper there. Again, I'm going to go quickly in a couple of minutes to give Lucy enough time to talk, but you probably saw this is making headlines in the news. This study that came out in JAMA this past couple of days. But it was a long COVID study they did on, I think it was like 13,000 people included in this study. And they found, they basically categorized using their computational techniques that one thing is, they categorized 12 symptoms that could associated with 6 months after, for long COVID patients, 6 months after your infection. Some of the key points that came out of the study is that, one, they've got a number that's saying after Omicron infection, which this number I think was previously kind of all over the place, but they're saying about 10% of people who have had Omicron will suffer long COVID on average. So that number is a little lower than what we were thinking of before, or maybe some same places others said. But the point of reinfections have always been gone up and down. There have been some papers that we've discussed said, reinfections don't make a difference for long COVID. Here, though, with this large patient population, and this is after Omicron, vaccinated and people or not, didn't matter, saying reinfections had a higher level of long COVID, meaning even after Omicron, there's up to 20% chance of getting long COVID after a reinfection. So that's from their large study. They pulled that out. Another key point was reinfections seem to increase severity of long COVID and is linked to higher long COVID frequency and severity. Again, this is after like Omicron infection too. So, and then one thing that I know there's been a few papers that have popped up in studies that said, anxiety, depression is one of these things, big common long COVID symptoms. But in this study, they did not find it. So it'd be interesting to compare, I guess, your patient cohort and see if other studies will confirm this with Omicron or not, or if this is an Omicron unique thing, or if this is a universal long COVID thing. But this is the 12 symptoms here that they said are the dominant distinctions for long COVID. And then this is kind of the sort of cutoff wherever they use. So some of these things are pretty, people know about, but.
Option did.
Oh yeah, go ahead. Kevin, go first, and then we go to Hannah.
Okay, great. Yeah, thanks. Did the authors make an attempt to make any mechanistic explanations for the results?
No. This is just a patient kind of epidemiology kind of study.
Yeah. Okay. Great.
Yeah. Anna, yeah.
So I was just wondering, when we're speaking of reinfections, was the implication both infections were Omicron infections, or just that there had been some reinfection in the history for that patient?
Some reinfection, yeah. So, I don't think they had enough data to say both were Omicron yet, since it's 6 months prior. So, but it's some reinfection. So, one of them was probably Omicron, and the other one
could have been a different variant.
Yeah, Delta or whatever previous. Yeah. So.
Okay, thanks.
They have a bigger table of patient stratifications too in there. So, which I don't have here, but yeah. But that could be another maybe discrepancy meant by people might see, depending on what strains are reinfected. I don't know. Maybe that causes.
Yeah, well, that was part of my thought process was whether the strain associated with the original infection, whether that alone would be a significant factor in, for example, the severity of subsequent long COVID.
Right.
But
Right.
who knows? I mean,
Right.
yeah, knowing what
Yes.
I know about, at least if when you're working from EHR data, usually the only way to, usually you have to guess what strain might have caused the infection based on the date of the infection, because, you know, there's not enough sequencing going on, or even if it went on, it's not recorded anywhere that you can get to.
Right.
So you just take your best guess as to what strain was circulating at the time.
Yeah, no, I agree. So sometimes that could cause more error too. So. Yeah, no, but that's I guess the limitations of EHR data, right? You're stuck with these things, and then you have to make
For
your
sure, yeah.
assumptions the best as possible. That's something maybe we could point out to a clinicians and say, "Hey, can you guys provide better?" But that's they won't do that. Here's another study that came out earlier. I guess advanced copy of it came out earlier this month. I didn't see, but it's I guess the actual publication's in July. But this is a study that talking about neurological post-COVID, you know, or COVID-19 past, you know, related activity. I might just put the methods and the results from the abstract here copied. But basically, what they're saying is that long COVID, they found like specific immunophenotypes related to neurological type long COVID symptoms. And this is one of the figures here. So they looked at B cells, for example, and one thing they said, all right, look, the CD or T cell memory and how that's infected with the CSF or the cerebral spinal fluid and activity in the neurocognitive area. And they're saying that probably T cells might have one of the big impact. Maybe the CD4 positive and CD8 positive, as you see here, are declining. Basically, your memory cells for T is declining with past because of long COVID, right? HV is your healthy volunteers, non-long COVID. So you can see how different that is from the CSF fluid, they're saying. And the B cell frequency, I guess it's a little increased, but it's not as drastic as your T cell population you see here. Although when you look at the secreting B cells, you see that drastic thing. So this is a nice paper that looking at different immune markers between healthy volunteers from the spinal fluid and then also from long COVID patients, specifically focusing on neurological type behavior that might happen because of this. So they have some also. It's a low population. It's 12 patients though, so I guess you have room for improvement to add more, but has actually nice statistics here from these 12 that are showing these differences. So it'd be good to see a follow up with a lot more patients involved. But I imagine getting the CSF fluid is not a fun thing for patients, so that's probably harder to recruit people for that. But it's an interesting study to look at different immune. Maybe the inflammation group might be interested in it. But okay, so let me keep going for the sake of time. The variance is still XBB.15 is the dominant one, but you can see XBB.16.19 is creeping up. The wastewater keeps showing decline nationally. I just showed Tony I live in last week. There's a slight bump going up, but you see these bumps happening still in wastewater, and overall they keep trending down. You can see nationally, no matter what region we're in, the wastewater is showing that, and I think it's probably the better indicator of where a spike would happen or not. So that's good to see. As the CDC tracker shows, again, XBB.15 was a dominant one, but you can see now these other XBB variants are creeping up pretty well. XBB.1.9.1, I should say, seems to be taking the few different versions of that, which are basically the same. Seems to be out competing the .16, but we'll see what happens, or getting there. And then overall, globally, the trends are down. But again, case reporting is lacking in everywhere. But hospital admissions and patient ICUs are for the countries that actually have accurate reporting of that, and deaths are going down. Okay, that's it. Maybe for the sake of time, I'll avoid questions and just turn it over to Lucy. Let me stop sharing my